The dynamic scaling policies we have analyzed so far are reactive in nature. That is, they respond to changes in metrics. Predictive scaling allows you to proactively increase capacity before demand occurs. It uses machine learning to predict capacity needs based on historical CloudWatch data. Therefore, predictive scaling uses historical data to calculate the capacity that best fits the historical load pattern. Predictive scaling is recommended when you have regular traffic increase patterns. For example, high resource consumption during business hours and low resource consumption during non-business hours. It is also recommended for applications that take a long time to initialize, resulting in latency. Since predictive scaling learns your traffic patterns, you can launch the necessary instances in advance, reducing the impact of latency on your application. Predictive scaling allows you to scale faster than dynamic scaling, which is reactive in nature. To set up predictive scaling, you create a scaling policy with a pair of metrics and the target utilization value. The metrics are the load metric and the scaling metric. The load metric is based on historical calculations and indicates the load the application has been under. The scaling metric is the metric you want to target or the metric you want to scale to. It is used with a target utilization value to determine the overall average utilization to be maintained. Here is an example. This configuration uses a couple of custom metrics instead of the pre-configured options available. In this configuration, the load metric is the total CPU utilization and will be based on historical data for the last 14 days. The scaling metric is the average CPU utilization, which is combined with the target utilization to forecast the required capacity. Here is another example that uses a pre-configured metric that is in the network. It is the number of bytes received by your instances. When you select a pre-configured metric, as in this configuration, the load metric and scaling metric are automatically selected by AWS and are not visible on the screen. When you create a predictive scaling policy, forecast creation begins if there is at least 24 hours of historical data. Create scaling patterns or traffic patterns on CloudWatch metric data from the previous 14 days to create an hourly forecast for the next 48 hours. Forecast data is updated every 6 hours, so if there are ongoing changes in traffic patterns, they will be taken into account when the data is updated in 6 hours. Now, the predictive scaling policy can operate in two modes: forecast only and forecast and scaling. The forecast-only mode does not perform escalation. It only generates forecasts so that you can evaluate them before deciding to actively scale. The forecast and scaling mode generates forecasts and scales your instances based on them. It is recommended to start in forecast-only mode and then follow the AWS recommendations. Finally, please note that the predictive scaling policy scales instances at the beginning of each hour. If your actual capacity, that is the number of instances currently in use, is less than the predicted capacity, a scale-out occurs. That is, more instances are added. If your actual capacity exceeds your planned capacity, that is, you have more instances than you need, no scaling out occurs. So it is important to keep this in mind. If your actual capacity is greater than the predicted capacity, AWS will not scale. Predictive scaling only scales out, that is, scale out and not scaling. Therefore, it is recommended to use predictive scaling with dynamic scaling. Predictive scaling scales based on the forecast, while dynamic scaling responds to real-time or unexpected load changes. Predictive scaling and scheduled scaling in AWS can be used together to optimize the capacity of your application. This is especially useful when you have additional information about your application's future needs that cannot be captured by automatic predictions. For example, if you have an upcoming promotion on your website and anticipate an increase in traffic, you may need a higher minimum capacity. In this case, you can use scheduled scaling to predefine the minimum capacity required during the promotion period. This ensures that your application can handle the expected increase in demand. So, with this vital information, let's go to the EC2 console and set up predictive scaling. Okay, Here I am in the EC2 console in the Auto Scaling Group section, and here is that group that we configured earlier. To create a predictive scaling policy, we go to Auto Scaling and then Create Predictive Scaling Policy. Here we can provide a name for the policy. Below, by default, the policy is in forecast-only mode, unless you enable this option to scale based on the forecast. In the next section, we can define the metrics and target utilization. You can select one of the pre-configured metrics, such as CPU utilization, network input or output, or application load balance request count. You can also choose to provide a custom metric pair. This allows you to select the load metric and scaling metric individually. For example, in this configuration, the load metric is the total CPU utilization, and the scaling metric is the average CPU utilization. They can also be different. For example, your load metric, which will be based on historical data, may be total network in, but the scaling metric, which addresses the required capacity, could be average CPU utilization. Below, you can define the target utilization value that is used with the scaling metric. You can also use a custom CloudWatch metric. This can be useful for forecasting and scaling based on a metric that is not in this list. If you select a pre-configured metric, such as CPU utilization, the scaling and load metric is automatically calculated by AWS and is not visible on the screen. Finally, in the last section, you can configure the time by which the instance launch time should be advanced. This way, instances will have time to pass status checks, run the configured scripts, and be ready to serve traffic at the required time. It can also be useful if your application takes a long time to initialize. By default, EC2 auto scaling cannot scale beyond the defined maximum capacity. When this setting is enabled, that is, the maximum buffer capacity above the predicted capacity, auto scaling can increase the capacity above its defined maximum capacity. This occurs when the predicted capacity exceeds the defined maximum capacity. In simple words, auto scaling can scale beyond its defined maximum capacity. Here you can define the percentage by which the planned capacity can exceed your maximum capacity. Let's say your maximum capacity is set at 10 instances, and you have allowed the service to exceed it by 20%. In this case, the service could increase the maximum capacity from 10 to 12 instances. After applying your configuration, you create the policy. I won't do it at this time because I have already created 2 and let them run for 24 hours. So, the first policy uses CPU utilization as a metric, and the second uses the network metric. Both are configured for forecasting only because forecasting and scaling is not enabled. The recommendation for the first policy is to switch to forecast and scaling mode. Here is a graph, which may be useful to visually understand the load and capacity. On the left we have the load, and on the right the capacity. The load graph shows the observed load in orange and the forecasted load in blue. This capacity graph shows actual observed capacity in orange, inferred capacity in green, and maximum capacity in purple. I close this. The other information included in this policy is the availability impact and the cost impact. The availability impact describes the impact on the availability of the application if this policy is enabled. In this case, availability would increase significantly. The other column describes the impact on costs if the policy is activated. In this case, it says somewhat reduce. Here you can also change the evaluation period. To get started, AWS recommends creating several predictive scaling policies in forecast-only mode that track different metrics. This will allow you to compare the impact of different metrics in target values and identify the best one for your scaling needs. If you have multiple scaling policies, the one that offers the most availability benefits at the lowest cost will be labeled as best prediction. So, here's how you set up a predictive scaling policy in AWS. This policy is useful for anticipating future demand for your application based on historical patterns. However, It is not designed to handle unexpected traffic spikes and cannot adjust capacity in real time. Therefore, it is recommended to use predictive scaling in combination with dynamic scaling and scheduled scaling policies. Dynamic scaling can adjust capacity in real time in response to changes in workload, while scheduled scaling allows capacity to be predefined based on known demand expectations. Together, these policies provide more comprehensive and efficient resource management for your application on AWS.